recording. So let me finish the stuff and then you can ask me questions, okay? Okay, this is the basic Python introduction. Python is a popular programming language. It's now widely used for web applications and for big data and performing complex mathematical computations. So it's widely used in the data science world. It's quite used in the data engineering world also. So what data engineering I mean is actually ingesting data into a data lake or any big data system and actually manipulating it to produce analytics. Data sciences is basically a lot of predictions, linear regressions, and all that stuff. So there's a little bit of a overlap as also a little bit of differences between the data engineering and the data science world. So, but Python is used across all these platforms. And one more thing you have to understand about Python is Python is an interpreted language. So it's very easy to write, and it doesn't compile when you just deploy the code. The most important thing is when it runs, it actually compiles the code, and that's when if you have any errors or something like that, your program crashes. So it's very important that you follow the standards of Python. That way you don't see all these situations at the end of the deployment. We want to catch the errors early. This is Python. So I just gave you a very quick introduction. So I'll move on and just do a few small little steps. So this is Python version, which is how you want to know which version of Python you're running. I strongly suggest people use Python 3. Don't go to Python 2.7. It's now like totally outdated. Don't even go there. You can actually, in this W3 schools, you can actually print yourself. So sorry, you can actually test your code. So if you write print, when you click try it yourself, it will print you this stuff. That's hello world in Python. That's how we write a print statement. And so Python, you can either do Python or Py, whichever you think is easy for you. Once you hit Python, you get the interactive shell here, and in the interactive shell, you can write all the statements that you want to execute. And in that session, it remembers all the variables. So if you have initialized any variables in that session, it remembers it in the next statement. So that's one good reason why it's widely used in Jupyter notebooks and Zeppelin notebooks. So all the data science people, they create notebooks and it's used in those notebooks. I'll show you how the notebooks are going to look like in the future sessions. And that's exit. Exit means to get out of the shell, or you can do Control D. This is hello world. And the most important thing in Python is indentation. Indentation is very important because that's how Python understands which block goes under which statement. So there's no curly brackets as in Java. So if you see here, there is a tab inside this. If you look at the statement, if 5 is greater than 2, there's a tab or a space, and there's a print statement. So this tells that if this condition is satisfied, do this. So if you have 10 statements at this indentation level, all those 10 statements get executed. Because there is no bracket system in this, that's the indentation will help it to understand how to perform the operations. So in this statement, it says is 5 greater than 2. So if this is going to be evaluated as true or false, in this case it's true, so it's going to print this. And you can write multiple, like this is how you write a typical if statement. If condition and a colon. So in Java there is this parenthesis that you use, but in Python you can put the parenthesis or you don't put the parenthesis, it doesn't matter. You can just still write it in this way and put a colon, and that's how it understands an if block definition. And the next thing is defining variables. You don't have to define the variable size. This is decimal, this is integer. It understands the integer type, like the variable type based on the assignment value. So if you say x is equal to y, it understands x is an integer, and y is equal to hello world, it understands y as a string. So you don't have to do that work. And comments. So this symbol, right, the hash that you see, that is a single line comment. If you want to write a single line comment, you just have to put a hash, and this is how it does a single line comment. So there are multi-line comments also, which I think it's going to be in the next. So this is how you write a single line comment, right? Let's suppose you have a multi-line comment that you can do it with these. You have to put 3 quotes. Then you can write a huge multi-line comment. So in production or any code, if you do want to comment something out, you just put a multi-line comment and just comment at the code. So that's how you can remove some code from execution. So you can test it yourself. All these you can do it yourself. I'm not going to run all this stuff for you, but I just wanted to walk you through everything so that you will have a feel of how it looks. So here he's doing a variable assignment. X is now an integer and Y is a string, at the way it is over here. And you can try all of this yourself. I don't want to do all this work for you. You can do it yourself. So here you can't have a variable type which starts with a number. So that's one thing. You can't have a dash. You can't have a space. So how you can define a variable is what is explained here. So you can't have a variable with a number on the front, and this one has a dash and this one has a space. And names are case sensitive. So if you have a variable, it's a case sensitive variable. So you can do a multi-variable assignment this way: X, Y, Z, orange, banana, cherry. X is orange, Y is banana, Z is cherry. In this case, all 3 of them have the same value, orange. And if you want to print something, you can do a plus X. That's what this says. And if you want to concatenate strings, you say A plus B, X plus Y. If you want to add the integers, it's X plus Y. Print X plus Y means it's going to do 5 plus 10 and it's going to become 15. And the next one is the global variables. So this one, I'll give you a little bit of an explanation. So when you define functions, the variables that you define inside the function block, they are function variables. So if I created a function def for my function and I put 5 variables here, they are under the main function. But once you declare a global variable, that variable is accessible in all the functions. So what happens is, if you write x equal to awesome, if you have 10 functions here, you don't have to define x again. Because it's a global variable, it's accessible in all the functions there. So if you have a local function, local variable and a global variable, the local variable takes a precedence. So let's suppose you have x is equal to good here, and you try to print x, the local variable takes precedence over the global variable. So you have to be very careful, because what happens is you get confused, like why is it not using the global variable? But you have to understand that the local variables take precedence over the global variables, and the global variables, if they are modified in different functions, you can see the modified value in the other functions. So these are called side effects. That's why object-oriented programming became so famous over the procedural languages. The reason being that every function, you have to understand the side effects of how the variable has been modified, and you don't have any amount of abstraction left. So that's why they created these classes, and they put variables inside them, class variables, and they put objects in it, so that any manipulation that happens inside the object stays inside the object, so that other functions and other procedures don't modify that value, and then cause a lot of confusion for developers, because now they're debugging how this variable got modified in the process, because it's distributed across many code bases, right? That's why it becomes very tough to debug. That's the most popular part of object-oriented programming. So here, Python, you can declare global variables. We do use global variables, but we are very careful when we use global variables, because it's just going to confuse you even further if you have any side effects involved in it. So this is an example. So x is equal to awesome, fantastic. So this is going to say fantastic. It doesn't say awesome. And this one is going to say awesome, because it's a global variable. So any changes that are done inside the function, any changes that, one second, I'm getting confused. Yeah, any changes you do to the function, it doesn't modify the value. So the moment you say it's global, then it starts modifying that word. So if you say global x, that means it's going to use the global variable, and then it's going to modify that value. So that's very important. You have to understand when you're trying to use a global variable versus when you're using a regular variable. So in this case, because I've said the variable is global and x is equal to fantastic, you can use it everywhere and this becomes fantastic. So you have x equal to awesome, and here if you said x equal to fantastic, this is going to print fantastic because you're modifying awesome to fantastic here and you're using the global variable x. So these are some things you have to try it yourself to understand how it performs. So basic understanding of it is when you use a global variable inside a function, you have to tell it that I'm trying to modify the global variable and this is the new value of that global variable. And that's how the value gets propagated if you used it in other functions. So you can try all of these yourself in your free time, and then that'll give you enough understanding of how this works. So the most common used stuff are these and bytes. I've never used memory view in my life. I used byte array. So I'll start with a very simple concept of what they mean. Data types are very important because your variables need a certain data type when you're trying to manipulate data. The first one is a text type, which is a string. So what happens in a string is if you wanted to say today is a great day or something like that, you need a string variable. Numeric types are integer, float, and complex. I've not used complex at all, so I've used integer and float. Integers are like numbers, which are rounded values, and floats are decimal values. So I don't think I think there's doubles also. I think if I remember, yeah, doubles also in Python, which you can set. And then sequence types are lists and tuples and ranges. So I can go into the I'll walk you through as I'm reading this stuff. Maps are dictionaries. So yesterday I tried to explain how a dictionary looks. So what a dictionary is a name value pair. So if you want to remember a certain piece of information and you want to remember it with a certain key, so you put a key and a value to it. So this is a typical usage of a map is, let's suppose you want to create an index of all the rows in a database or something like that. So you have a key and you remember where that row has been saved in the database. So those are like a typical usages of a dictionary. But in typical coding world, the reason why we use dictionaries is if we have to when we're manipulating data, if you need to remember what these keys mean and what are their values are. So I'll walk you through a little bit of an example of what these dictionaries are used for. Sets are unique set of values. So if you want to store, if you want a data structure to store unique set of values, you put them in a set. And Boolean is true or false if you want to have a true or false condition. And bytes are binary types, wherein if you have images or if you have something which you want to carry that information as form of bytes, you can actually carry them as bytes. And byte array is an array of bytes. Okay, so let's do this. X is equal to 5. The type of X is an integer. That's what this is doing. So if X is equal, the type will tell you what type Python has has come up with when you've done the assignment. So it actually dynamically identifies your data type. So in this case, type is integer. So here here he's actually walking you through all the list here. So X is equal to hello world. Hello world is definitely a string. 20 is an integer. 20.5, all the decimal floating points have become floats. I think this is what is that, hex values or something like that. I've not used complex before, so we don't use it very often, but if you want, you can have a try. So this is a list. So if you want to have a list of information that you want to read, so I'm going to read a list of variables and identify what is the smallest number in this list. So that's the list. And a tuple is a list of values. So you can have it is a little bit difference between a tuple and a list. You can have multiple tuples. So I'm just going to write it down here. Give me 1 second. So it's a one-dimensional tuple. You can also have tuples like this, 1, 1, something like coordinate, like if you remember coordinate geometry or something like that, like these. So these are all types of tuples you can have. And then range, I don't remember. Oh yeah, range is 1 to 6. So if you want to use it in for loops and all that, you can have a for I is from this range to this range, something like that. So So this is a dictionary. If you want to remember a person's information, you can either create an object or you can use a dictionary. The name of the person is John. The age is 36. So that's the dictionary. So you can create objects saying that this person has name, age, profession, all that information. Or you can create a dictionary which has a name, age as name value pairs here. So I would suggest you read about maps. Maps are a direct mapping to dictionaries in Python. I don't want to go and sit down and explain maps here. You can go ahead and study it yourself. The next one is set. Set is a unique set of values um, in a given data structure. So if you want to add apple to this list, it will again show up as apple. So you want to know the unique set of values that are available in your program. That's when you use sets. I've not used frozen sets, so I'll skip frozen sets. You can read it yourself. I don't think it's usually widely used. The next one is what is that? Boolean. Boolean is true, false, and bytes. If you want to write, I mentioned this. If you want to store this in bytes form, a given string, you can just put B there. Bytes are typically used when you want to read files or something like that, or you have binary information like images and all that. That's when you use bytes. And byte array is another database. Another data structure wherein you are actually trying to you're creating 5 bytes of an array. So that's a byte array. I've not used memory view. Please go ahead and study it yourself. It's not widely used, so it's not a very common data structure. So you can set data types like this, which is not typical in Python. People just assume that Python is going to dynamically figure out what the data type is. Yeah, so in float complex, he's actually telling you what these types mean. So integers, there is no 32,767 typical type of limitations like in Java. So if you have Java integers 32,767 and then you have to use a long and then you have to use a big int, there's nothing like that in Python. You can just use it. And floats, you can use floats as they are. I think there used to be a double. I don't remember if there is a double or something like that. Or I got confused. So I've not used complex numbers in my life, so I don't know what they're trying to do with the complex numbers. So please feel free and study, but it's not going to make a big difference because you're not going to use it a lot. Random number is actually giving you a list of random numbers between 1 and 10. So this is a random number. So this is a package. So in Python, if you want to use a certain package, like in Java, if you want to use certain, same thing, like packages, you also do an import. It's very, very similar to Java in that case, wherein you do an import random or import math, import, what is that, skikit. So these are like very, very simple import statements wherein you want to use a certain function that's already been written for you, but you just want to use that function. So that's when you do an import random, and in using that random, you're going to find you can use a function inside that package and generate a random number between 1 and 10. That's what this is doing. So basically what it does is it does an import random and it prints with random numbers between 1 and 10. Casting, yeah, you have to, there are certain situations where you have to cast the numbers. So sometimes you have a decimal, you want to cast it to integer, then sometimes you have an integer, you want to cast it to a decimal, or you want to cast it to a string. So these are casting to integers. It'll cast everything. So if you have a 2.8, then it's not doing a rounding, it's actually doing a casting. In this case, it just casts it to 2. It doesn't cast it to a 2.8. Same thing with the float. If you want to cast it, you can cast a string to a float to a string, and all that stuff. So you can do all that stuff. So this is a very simple thing if you want to convert between data types. So one thing, I'm going to pause this recording and I want to take some questions. Give me 1 minute.